I got the wrong end of the day, that's for sure. I'm pretty tired, I don't know about you. I'll try to be pretty quick. So my name is Alex Timbs. I work for Dell Technologies. I'm a Business Development Alliances Manager. I've been working with Dell for just over 5 years now. And I focus on media and entertainment. And you might be going, what is a media and entertainment guy doing here? Well, I don't think it's too long a bow to draw to say that the challenges that media and entertainment face in terms of data sets, managing data, getting insights from data are very, very similar. So I believe that the parallels between content creation and research can be drawn pretty quickly from the innovative use of data that is ultimately used to shape understanding and engage an audience. At least that's my take. And after having a few meetings, not many, with researchers and universities, even some this week, I can say that the data sets are fairly similar and the challenges are very similar. So that's kind of been confirmed. A recent report by IDC stated that the average compounding data growth is around 23% year on year. And I spoke to a university just this week in New Zealand, and lo and behold, their estimated data growth is 23% year on year. So that was some validation I got from them. So the staggering growth is also accompanied now by AI and the ability to generate data a lot faster and a lot more of it. So this is expected to grow, bringing further uncertainty to the capacities required that come out of these technologies being used. And as we continue to generate more data than ever before, the challenge remains, how do we ensure that data is organised, accessible and useful for driving innovation and decision-making in our organisations? There's also an element here of power. Data centres are expected by 2030 at the current rate of growth to consume around 4% of the world's total power, although CDC might be able to give us some more accurate figures. So talking about my journey, my timeline, because that's the point of view I'm coming from. If you look at 2005, this is a project I started working on in about 2004. This was Happy Feet. Hopefully some of you have seen that movie. The 64 terabytes represents the final images and the dependencies to make those images on disk at the completion of that film. And it consisted of roughly 8 million files. If we fast forward to say 2020, that was Peter Rabbit, one of the last movies I worked on before joining Dell Technologies. It was 3.9 petabytes and consisted of almost 500 million files. An extreme outlier, this is from a VFX studio that I'm friendly with. In 2022, 25 petabytes. Final images and dependencies. So not all of the data generated. There was probably 6 to 8x more data than that generated that was deprecated and thrown away. So you can see the growth here is huge. And that same studio, as of this year, is expected to, on a single film, use 45 petabytes of storage and billions of files. So the problem's getting out of control. It's a very large problem, and they need to get rein in control of that, whether it be media and entertainment or whether it be research and universities. One of the biggest problems as well is how do you protect this data and how do you deprecate the data? How do I know I can delete that data and how do I know that data is protected? Traditional means of doing that no longer make sense. But first of all, before we continue, I wanted to, and I'm sorry for rushing through this because I'm under pressure here with time. One of the simplest and best answers that I've ever heard about what metadata is came from a gentleman in this room, Jason over there, Architecta, and he said that metadata is simply the ability to answer questions about your data. And I thought that was a really elegant way of answering that. And so I've taken that and I'm using it today. So if we look at why automation of metadata and newer technologies such as AI and machine learning are so valuable in media entertainment at least, we can look at a 3D production pipeline, a linear pipeline. This is what it looked like when I started working on Happy Feet. You have an idea, you develop a story, so on and so forth, and out the end of it, you start popping out some images. The problem with this kind of approach to generating data and managing data is that when there's a change, like a director decides he wants to add a character, or someone has a really good idea to change a look, you have to go right back to the start and push it back through there. It's really costly. So we started to try to organize things a bit with the file system. So in this linear pipeline, we created a really, really basic tree that looks something like this. You had a project, and under that you had craft groups, those individual departments that are responsible for certain elements of that process. It became apparent pretty quickly that we needed to introduce more structure, so we turned our attention further to the file system. And we have multiple different projects running at the same time, remember that. And you have this concept of assets, which are really abstracted ways of looking at files or data. And you have lots of branches underneath that, different classes of assets. And under each craft group, you'd have shots, scenes, etc. With the ever-increasing number of people that were joining the company, we needed to find better ways to collaborate. So in the absence of a global namespace or an asset management system, or any major automation, we turned to further enhancing the file system parts, and essentially used the tree structure to define what happens with assets and started writing scripts around that. So from movement to the next department, from archival to do deprecation and deletion, policy-based approaches added complexity, but they could be very granular. And this essentially, as I mentioned, uses scripts. So list-based management was also used in this situation where we were generating from production a list of assets that could be deleted or have something done with them. But path-based approaches only get you so far. So we started tracking dependencies. And the principal reason to do this was to track every file and asset in production to be able to understand how they relate to each other, normally referred to in our neck of the woods as dependency tracking. And this represented here in a graph is a really simple description. You guys probably understand this. And one of the reasons to do that was the ability to recreate data if needed. And we started to drive things with production management systems. So we wanted to capture information from creative people that weren't technical, around the status of a shot or a scene or an asset. And with those statuses, we could tag that data and start to drive even more automation. And these are some of the common ones that we use, things like active or dropped or could be better, CBP. So in reality, the modern animation of VFX pipeline started to look like this. It's an incredibly parallel, non-linear process, and it had at the center of that storytelling, but that could be translated, I think, to a lot of different verticals. The idea was that creativity and storytelling and ideas needed to be constantly flowing, and every output was an input to another department, more akin to continuous software integration than anything else, I think. And one of the other things that we learned in that journey was the importance of making your assets really atomic. And by that, I mean making them really small and tracking them at a very granular level. I'll give you a really good example. And the reason I got this picture from one of the Lego movies up here is that we tracked the individual logos on the studs of every brick that were represented in three-dimensional space. An extreme example of that would have been Lego Batman, Lego Gotham. In one of the biggest scenes there were 256 million individual bricks represented in three-dimensional space. So we had Lego Corporation say, you can't use a brick for a scene. What do I do then after I've already made the movie? If I was in a linear process, you can imagine how expensive that'd be. We also had a director say, I don't want to use that to make a wizard's wand. It was a combination of a flower and something else. I don't want to use that anymore. I want to use a different type of brick. Again, we could, with this atomic approach and that dependency tracking, you can automate that and re-render the film. So this is really good if you want to recreate things. That's the importance of tracking it at such a granular fashion. So we could even change the logo on the studs if we wanted to. That's the value of tracking it atomically. The remiss of me not to mention AI. I bet everyone's kind of getting sick of that buzzword, but it is very important in media and entertainment, along with rich metadata and vectors, which can represent things in high dimensional space. Elements of AI, including computer vision, natural language interfaces, and enhanced predictive analytics, can search through and help you search through really large data sets, so making the impenetrable penetrable. Vector-based analysis allows organizations to find more meaningful relationships between what look like very different types of data. And that can be valuable, I assume, in research. It certainly was valuable in media entertainment. And obviously also being able to manage assets more intelligently, which includes data management. So in media, vectors and AI have helped transform asset management by automating time-consuming tasks and providing powerful analytics that we didn't have before. Things like automated tagging and classification with computer vision, predictive asset retrieval, so being able to predict what assets might actually be needed to be pulled from, say, a deep archive ahead of time. Quality control, so we've seen the early signs of AI doing, the first 99% of lifting of looking at individual frames in a movie to find out if there are anything wrong with them. Are there dud pixels in there, or is there something that's gone amiss in the rendering process? Real-time asset tracking, so being able to provide real-time tracking of an asset and how it's being used in production to give you business intelligence, or production intelligence as we called it. Efficient resource allocation, so we used to have a big 80,000 core farm, and we used to fire that up dynamically based on the demands that were coming through the pipeline. We used to do that with some scripts and knowing the kind of classes of data, but I know that some organizations are now starting to use machine learning to identify what kind of data is coming through the pipe and what kind of resources would be required to manage that. We also did things like Darwinism. So we used to, this again is not AI, but certainly used some algorithms that were fairly advanced, but we used to weight individual users' effectiveness of using resources, in this case compute. And if someone was inefficient in their use of that resource against a norm or curve, we would then put them down the list. So it's a way of getting users to compete for a resource, make your render more efficient, use it more efficiently if that's a class of data which has some kind of metric against it. And obviously data-driven insights. Talking now quickly about visualization. So generative AI in particular has made some huge inroads in media and entertainment. Here's an interesting pipeline from one of our customers. This is an actual customer's pipeline. You'll notice that they've got Unreal Engine at the center of this. So they're using a game engine for real-time visualization. So it means they can get immediate creative feedback from the director. And what I want you to take away as well from this is that they are able to publish assets for both games and movies simultaneously. And they've added or started to add AI to a lot of these areas. They're able to do things like use AI to control character behavior in the midground and background, so they don't have to animate them. But they're unique. It's not just traditional ways of doing crowd simulation. They're also starting to use things like AI chatbots, if you will, for use of a better description to create natural language and actually do drafts. Thank you. Here's a real outcome of this. So this is Kennedy Miller Mitchell. This is the creator of Mad Max. You probably might have seen Furiosa, one of the my most recent movies there. They got a 50x performance gain by using these techniques, not 50%, 50x over their previous pipeline. So in just 2 years, 50 times the performance of the previous approach. I asked George Miller, what's in it for you? Because he's not, I wouldn't say he hates technology. He's a creative. He likes to film people. He likes actors. So I said, why have you embraced this technology? And he said, because it allows me to make the film before I make the film. It allows him to reduce risk. And the takeaway here is these new technologies are removing the risk in doing something and failing. So in creativity, it means he can make a really high quality version of the film that you can go to the studio and say, I need more money. They go, wow, this is pretty good. I get it. I know what you're trying to say. Whereas before, it was just words and drawings, and it's really hard to read someone's mind. So I think the same can be translated to just about any industry. The core value here is reducing risk of trying something. Another customer, I'm almost out of time, is Heretic Foundation. So this is Alex Proyas. I don't know if you know him from Dark City, iRobot, pretty famous director, and The Crow, another famous movie. So he's making a movie called RUR, Rossum's Universal Robots, and it's based on the 1920s Czech play by the same name. And he's very fortunate that he's given me permission to show some of this, just to show the value to them again in media and entertainment. What I want you to take away from what I'm going to show you is what you're seeing here. They've done in 7 weeks, right? From getting the movie greenlit and getting some money, 7 weeks. Normally, this is per Alex Proyas, this would have taken 12 months to get this point. So he's approved a whole lot of stuff off the back of this. Playful little play. How embarrassing. That was pretty honest, but it's not critically important. So this is him just using generative AI. They're using Stable Diffusion, and you use Stable Diffusion 1.5 because it's got a lot of knobs on it. It's very proven. They're also using Flux. He's exploring the environments. So there's this huge environment he's creating. They're then trying to add some physical lighting to it, and he started to approve these environments. And then he's going to put it through something called Cog Video X. All of this was open source, and he's going to do a fly through the environment to get a feel of the scale of it. So this is after it's run through Cog Video X. He's got a 3D environment. And then he's going to use the virtual volume and put the actress, this is an actress from the actual film, stuck straight in front of an LED wall, all 7 weeks in. And he's already approved a whole lot of scenes as a result of this, and the 3D. So that's just an example of the real outcomes that are possible, at least in media and entertainment, using this open source technology. Quickly, wanted to mention AI Threatscape. There's a whole new generation of threats coming through. It's not a traditional world anymore. AI is being used particularly well for social attacks. So scraping LinkedIn, scraping your socials, and it's coming up with a campaign automatically and targeting you. I know personally the phishing attacks on me are so good these days. And the stat I read the other day was they're around 50% or over 50% successful with these new approaches, the AI doing it, versus around 12% where humans used to create these campaigns against people and companies. So you've got to be really careful and prepared for that in your environments, regardless of what industry you're in. So I thought I'd just take this opportunity to mention it. Adopt the framework, doesn't matter what it is. There's some really simple ones like the ASD8, which is an Australian Signals Directorate one. That's quite straightforward. There's ISO 27001 if you want to go deep down with an AI-specific framework. But have a process, have a plan, have a response team to being breached, because this stuff is happening. I'm seeing it all the time in media companies in particular. And one of the most important things in my experience was teach the individuals within your organisation their individual responsibility and to be aware. And it can be 30 minutes once a year will make a difference in getting that message across. We do have some I heard security mentioned a few times these past few days. I do have a number of reference architectures. I can give these to people if you're trying to design a more secure network. These are M&E focused, but the concepts are identical to what you might want to achieve. So feel free to email me if you want. Thank you very much for listening to me. Hopefully I made it on time. Come speak to me if you want to talk more.
Thanks, Alex. That's really cool.
No, sit down. I have a question.
You did.
Now, just a quick one. I was really interested in the auto tagging part. I can see how it's done with computer vision, but when you have unstructured data sets, have you seen any off-the-shelf-ish technologies coming up that you could let loose in a data archive for scientific data and get something useful out of there?
So this is Jason from Architecture. I think some of you may already know him or have met him. Architecture is a partner of Dell's. And in my entire career, again, most of it has been media and entertainment, but it's big data problems, as you've seen. Millions and billions of files. The most comprehensive solution I've seen to date is probably from Architecture for that, penetrating the impenetrable, very focused on identifying what's in very large silos of data. There are solutions out there, and just start talking to people. From an M&E perspective, and Animal Logic, formerly or now known as Netflix Animation, the challenge was always to, how do we try to prevent us getting to that point? How do we prevent us getting to the point where we actually don't know what's in there? And so we learned very early on to start building systems that were capturing the data at point of creation, whether it's an individual or a system, and to capture as much metadata that was relevant for managing that data. We also created a tool called WMD, Weapon of Mass Deletion. And so this was a list-based approach to deleting things randomly. So it wasn't directories or any of that stuff. It was a list that came from a production management system. And we had to agree as a company, because there was a cost to all of this, a tremendous cost to storage, on what we were going to do. Most of it ended up being, we're going to keep the last 2 versions and dependencies, because some of these things had 1,000 versions, and there's a huge cost to that. And so if we can agree as a business that's what we're going to do, and we understand the cost to regenerate these, and we're tracking the dependencies, it's okay. There were certain classes of data, like fur cache, for example, that might have taken 80,000 cores 3 days to create for a rabbit. That's expensive, right? And you don't have the resource unless you want to stretch in the cloud and pay a fortune to do that. And so we class that data as pretty important. So we might decide to keep that on storage at all times because everything was using that. Or things like textures or, other simulation work that was expensive to compute. But for the most part, we only want the latest 2 versions, and it's not too expensive to recreate it if we needed to. And we've got all this metadata, which helps us identify that. We get lists every week, and we hit a button, and it uses the entire farm at the time to delete those files efficiently.